Welcome to another broadcast from MindYourHealthcast.com. I know you are sitting anxiously on the edge of your seat awaiting the broadcast that we're going to have today. Well, you know, I'm kind of kidding, but I hope you were kind of anticipating it. It's a subject that most people are unaware of, although I've seen growing interest in the last several years. To me, it's a subject that I've been involved with for many, many years. I know about it, I've read about it, studied about it, I've known high-level practitioners of it. I've actually made use of it in various ways myself, so I've already made up my mind as far as what my personal feelings are about it. But we're calling the broadcast Radionics, Fact and Fiction. And now that may seem like a bit of a contradiction, and to a degree it is, because a lot of things about radionics does appear to be a fiction, but at the same time it works, so that makes a kind of a state of cognitive dissonance in people when they believe what they believe, but then find that things operate differently than what they believe. So we're going to do a little bit of paradigm shattering today, and I'm sure you remember about the term paradigm, which means a border or a box that outlines what is valid on the inside and everything outside the box is invalid. So we're going to be talking about a subject that kind of fits in that category, that it's a paradigm breaker, because even though the effects are demonstratable to people, and people who have experienced it will say beyond a shadow of a doubt, yes, it's working. At the same time, there are those who think they are more scientific, who said, no, that couldn't possibly work, it's just no way, therefore it doesn't work. And so it makes a bit of a contradiction, and I hope we can clear some of it up, because as we talk about this subject, we have to introduce it with another subject, and in so doing, I'm going to already start your, what I want to say, analytical part of your brain being presented with some paradoxical information, and hopefully that will be the setting then to move on to radionics. Now, I held up the book last time and showed you this is one of the newest books out on radionics. There hadn't been any published in many years because the whole subject came about at the turn of the century of the 1900s, early 1900s. And consequently, it came out, became very well known, had its peak, and then the critics prevailed in suppressing it, especially in this country. Now, it's not so around the world, but in this country it has been suppressed. And so therefore a lot of people have never heard of it, and it sounds too hokey to many people to be really valid. Now I'm just going to read you the basic definition from this text to kind of lay the foundation for it, and then you'll see as we move on through the material how it all comes together. So the question is asked, what is radionics? Simply put, the basic concept underlying radionics is that all living organisms, including humans, have a complex energy field that must function in an ordered manner for health to result. If this functioning is disturbed, then illness may occur, and the symptoms experienced are for the most part a reflection in the physical body of the disturbance to the energy field. Now, it sounds like something from Oriental medicine and acupuncture, and in a sense it really is. If you believe in acupuncture, which I think there's probably fewer and few people who don't believe in it today, but I remember a time before President Nixon's visit to China when it was considered totally hokey. Couldn't possibly work. There's no known scientific principle by which it could function, and therefore it must not be any good. But when President Nixon's doctor went and sat in on the surgery where a couple of needles were inserted on each side of the body, and they were able to cut through the tissue with little or no bleeding, and the patient being fully conscious, actually sipping on some Chinese tea, and watched the chest cavity opened and a lung removed with the patient being in no discomfort. It was kind of a shock or a paradigm breaker to the doctor. And when he came back and talked about what he saw in the hospitals and from the doctors practicing Oriental medicine or acupuncture in China, it started a whole new movement in this country, which resulted in now almost every state, if not every state, I think it's almost every, now has a state license to practice acupuncture. They also have actually removed, surprisingly, acupuncture needles were considered at one time to be a experimental medical device. That's how the FDA had classified them. Now, because the states had passed a law that it was legal to practice, the people are using it, but the FDA still considered these needles were experimental medical devices. And one of my friends who has been in the field for years also and did a tremendous amount of digging of research from only all over the world, but from the U.S., presented about a 3-foot high stack of research papers showing that in fact it did work, even though people weren't quite sure of the mechanism, how it worked, as was the objection before, where there's no scientific principle by which it could operate. And consequently, what ended up was that it was removed from being an experimental medical device, and therefore it's fully recognized. Insurance companies now pay, in a lot of cases, for it, although they don't want to, the same as they accept chiropractic, but they don't want to pay for it because the medical establishment doesn't want people taking their business, and if they paid insurance for it and more people went to it, it would come out of their pocket. So it's really been a turf war as opposed to a truly scientific war. At any rate, the information is out there, and again, I say don't listen to me. Take my provocation and go start digging up for yourself, and you'll find that pretty much what I say is accurate. I'm not saying that I might not stumble once in a while, but not too often. I usually do my homework pretty well. At any rate, that's an introduction to radionics, and it sounds very much like some of the information that might come out of acupuncture. Now, I'm going to throw a couple books at you that I have before, and you may or may not have gotten one or both, and you may or may not have read them. But I would suggest, before you start drawing lines about a lot of things, and before you start buying the propaganda of the medical establishment, who considers anything that comes along to be a threat to their turf and their income, they fight it. But go look on your own and you'll see that basically what I'm saying is accurate. The information is there, and it was convincing enough to state legislators in various countries, countries as well as various states in this country, to pass legislation that made it a practice. In some cases there were some court issues involved, but ultimately it resolved in favor of the Oriental medicine being valid. Now, the two books I mentioned are by Dr. James Oshman, PhD, who has actually a PhD in science and research. Got interested in alternative or natural medicine many years ago, and he started researching the literature for published studies that would verify the practices of natural medicine, or alternative medicine as it's called. I don't think it's alternative. I think modern medicine is the alternative. The other stuff has been around for thousands of years. But at any rate, if you look at his two books, the first one called Energy Medicine, The Scientific Basis, and the second one called Energy Medicine in Therapeutics and Human Performance, both of these volumes cite all that he found scientifically that verified the effects of all these different therapies. So in those two books, he covers pretty much everything that you hear, read about, or have seen or experienced related to the real medicine, which I really refer to it as the real medicine because it gets people well. that they have been using has already been researched in scientific circles and published, but nobody brought it together. So he brought it all together in these two books that demonstrates that yes, there is a scientific study showing the effectiveness. Now, as I said, with acupuncture, they may not understand the mechanism, although I think I do. I've been involved with it since about 1968, somewhere in that area. And I'm convinced that it works. And I'm convinced I understand how it works, because a lot of research in Europe has demonstrated that there are, in fact, minute protein chains that form fibers that go through the body that carry photons and electrons and phonons, which are sound waves, and therefore are capable of being stimulated and have an effect on all the functions of the body. It first was done in Korea, actually, by a doctor by the name of Kim Bong-han, and when he discovered these vessels, he referred to them as Bong-han vessels. Now, there were skeptics of that, but then later a researcher in Austria by the name of Pischinger and a group of doctors involved with him were able to prove the same thing. So what we're talking about basically is an energetic system in the body that has to do with health and sickness. And when those energetic systems are disturbed or blocked in some way, which they can be either mechanically or electronically or chemically, then things start to malfunction. So first we have functional disturbances, which ultimately may lead in many cases to pathological disturbances. And so Oriental medicine has become a very viable system to help people get well with all kinds of things. But of course we're not on acupuncture, but because of the fact that what we're talking about is also energetic in nature, they basically all fall under the same big umbrella in my mind that has to do with body energetics. Now, of course, there's some ways in which radionics is administered, which is really dumbfounding. And so to have some understanding of that, we need to talk a little bit about quantum physics. Now, the field of quantum physics is quite interesting. It again runs counterintuitive to what we believed. And what we believed, of course, has been provided for us by one of the newer religions of the world called scientism. Now, there is science, but if you understand science and scientific method, it means that a scientist approaches any subject unbiased and awaiting for data that he can consider. Now, it may be provided to him, or he may, on investigation, produce his own data, but he is basically to be unbiased and look at all the data, and when he has all the data that's available, then organize that into some information that may suggest a hypothesis as to what's going on. Now, that hypothesis, of course, stands to be corrected because it is a hypothesis, and it's a quantum jump from hypothesis to established fact, although in many cases that intermediary step gets bypassed by scientism, and scientism are a group of people who consider themselves to be scientists, who believe that what they think and what they believe is all there is. Now, you tell me if it's scientific to approach a subject when you already have said, well, inside this paradigm is what is valid and outside the paradigm is not valid. Therefore, if this isn't inside the paradigm somewhere to begin with, we're not going to even bother looking at it because it couldn't be true because it's outside the paradigm. And so that is scientism, the religion, who says, look at us, we know it all, and therefore the way we say it and see it is the only way it is. And of course, there's certain assumptions that we have that can't be true. And why are they not true? Because we have said they're not true. And so now it gets into what I call a circular argument. It's true because we say it's true, and how do we know it's true, et cetera, et cetera. It just goes around the circle, but it's not proof of anything. In fact, to me, it's very unscientific. Scientism is. But, you know, how many times do people say, well, science has shown that, or science has proven that, when in fact it's probably a bunch of baloney, but because you attach the term science to it, well, people say, oh, well, if the scientists say it's true, then it must be true. But, you know, as I've mentioned before, I remember many years ago when I was a young man that scientists in the field of medicine said it was impossible for a human being to run a mile faster than 4 minutes because they would collapse and die from total exhaustion. That was a scientific fact until it was broken. They also said when the automobile came along and people, as people will do, noticed that it had an accelerator on it, which means we could make it go faster. And so they got into racing automobiles. And the magic number was 60 miles per hour, a mile a minute. And science, medical science, said it's impossible for a person to pass 60 miles per hour because the pressure against their chest would force all the air out of their lungs and they would die. So that's the speed limit that we cannot exceed in a car. But guess what? I remember when the ground speed record was broken at 600 miles per hour with a jet-powered automobile. So all of this, these things you hear so many times that science has said, it really wasn't science, it was scientism, the religion. And so a lot of people adhere to the religion of science, and unfortunately that's not true science. So I had to lay that out first because now as we talk about quantum physics, we have a lot of scientists who have found out about quantum physics and embrace the principles even though they run counter to what scientism says is factual. And it all started heavily way back at the turn of the century. Now we had Albert Einstein, which hardly anybody, I'm sure, well, I can't say that anymore. There's a lot of people interviewed on the street that don't seem to know anything about anything. But generally, I would say there's hardly any, at least partially educated individual that has not heard of Albert Einstein. Well, he, of course, was considered to be a poor learner. He didn't speak hardly at all till he was 6 years old, didn't do well in school, failed his first entrance exam to the University of Switzerland, declared he was going to study physics, and after 2 years, the head of the physics department said, you might as well forget it, you'll never be a physicist. Another scientific statement, I assume. Anyhow, he went on to rock the world. When he first published his theory of special relativity, the scientists reading it started snickering, how ridiculous, until they read it a little more thoroughly. And when they read it a little more thoroughly and it hit them one day, they quit laughing and they realized he had contributed a major concept in the world of physics. So he was considered the man for some time. Now, interestingly, Albert Einstein did not receive his Nobel Prize for the special theory of relativity, which is what the E equals mc squared, which hardly anybody, again, that has any education at all has not heard of. Energy equals mass times the speed of light squared, which is the conversion factor between matter and energy. And what he said is that energy can be converted into matter and matter into energy, and keep that in mind as we talk more about all this stuff because there is some application. At any rate, it ended up that a major physicist in Great Britain, and I believe he was from Cambridge, at the turn of the century made the statement that it really would be kind of a waste of time for new students to get into physics because everything that can be known has already been discovered, and therefore it would be a waste of time to get into a field that is already completed. And of course, that's one of those understatements of the century, because in short order, Dr. Einstein was considering a problem called the photoelectric effect as to how that worked. And you may or may not know, you may have seen it but not given it any thought. The photoelectric effect means that it already had been established that light was an electromagnetic wave traveling through space. And consequently, however, they noticed that when this beam of light would show on the surface of certain metals, it would start knocking electrons out of their orbits in the metal. And they said, well, how can that be? How can an electromagnetic wave knock physical particles out of their orbit? That can't be true, so there's a problem here. So Dr. Einstein approached the subject and began to analyze it, and eventually he said, oh, here's how it works. Light, under certain circumstances, appears as a wave. And under certain other circumstances, it behaves as a particle. And when it's hitting the surface of certain metals, it behaves like a little particle that hits the electrons and knocks them out of orbit. But when it's not being shined on that piece of metal, it doesn't act like a particle, it acts like a wave traveling through space. And in his paper, after he published it, it was that work that actually got him the Nobel Prize. But in any case, you know, that became a contradiction, because how could something be a wave sometimes and a particle sometimes? And so that became the wave-particle contradiction, and that opened a whole new arena of things. Now, he said that when it's acting as a particle, he referred to it as a photon, and that's where the term of photons came from, is that was when light behaved as a particle. Now, down the road, there were later experiments. I'm not going to even have time to get into all those, because we're just going to lay the foundation today for the radionics, and it certainly looks like it's going to be a two-broadcast subject, but we have to get this basic information in, because then it will start to make a lot more sense if we understand something about quantum physics. So, based on some of Einstein's ideas, some other people got involved, especially when we got into this particle-wave contradiction. And so there was some other physicists who said, now wait a minute, if something that more often is a wave can sometimes behave as a particle, then maybe particles, i.e. electrons, sometimes can behave as waves. And so they concocted an experiment called the double slit experiment, which in fact ended up coming out that way. Under certain circumstances, the light was behaving like a wave, and under certain circumstances it would behave like a particle, and electrons would do the same thing. If you fired a beam of electrons one at a time through slits, if two slits were open, it went through both slits at the same time and behaved as a wave. If one slit was open, it went through one slit and behaved as a particle. So it depended on how you set up the experiment. See, that began to rock the whole rationale of physics that thought everything was cut and dried. It's this way, this way, this way, this way. And so some very brilliant minds like Werner Heisenberg came along, and he said, well, you know, even further, it appears that you can't know everything about a particle. In other words, if a particle's moving, the more you can know about its velocity of travel, its acceleration, however you want to say it, the less you can know about its position. And the more you know about its position, the less you can know about its velocity or acceleration. And people say, wow, you mean it depends on how you look, what the outcome is? Aha, we had an interpretation that grew out of all that called the Copenhagen Interpretation, which Werner Heisenberg was from Copenhagen, and he and a group of scientists sat down one day and said, we've got to make some sense out of all this stuff we're finding out. And so they said, in essence, the particle really doesn't, like an electron, doesn't even exist until you look for it. And depending on how you look will determine how you see it. And so therefore reality is influenced by the way we view things. And they said, when you set up an experiment, what's going on in your mind can affect the outcome of the experiment. And of course that really rattled everything, because the scientist who had developed scientism, the religion, said, no, can't be true. Everything is solid material, because after all, we go back and look at Newton's work, and Newton showed that the universe is like a clock and clockwork, and once you establish the mathematics, you can determine what will happen in the future, and you can determine what has happened in the past from the mathematics. And in a sense, it was partially true, and to a degree, it's true. In other words, it gives you an approximation that, for all practical purposes, is helpful when you're navigating out into space and certain things, and to calculate positions of planets and so forth. It tends to work. But when you get down to the subatomic level, it falls all apart. Things are not the way you think they are. They don't behave like that. And so this kind of rattled everything. And this uncertainty principle got Einstein very upset, actually. Even though his work laid the foundation for it, I don't think he realized all the implications of what he had come up with. And all of a sudden, he and some of the physicists said, now wait a minute. God doesn't play dice with the universe, you know. The things are absolute. It's just for us to discover what those absolutes are. And so, see, it didn't stop there. Then another physicist comes along, and his name is Bell, and Bell developed the concept of nonlocality, which means there's no such thing as an event only affecting the locality in which it occurs. It affects everything, everywhere, at the same time. And so one of the outcomes of that was, he says, if you take two particles, whether two electrons, two photons, or whatever, and that are in close proximity of each other, they have influenced each other. And when you separate those, no matter how far you separate them, if you change one of them, instantly the other one changes in relation. And that's called the non-locality concept, that nothing just affects it locally, but whatever you do here affects everything else that was in contact in the universe, and it does it instantly. And of course that was really upsetting to Einstein. He said, now wait a minute, we've already established with the special theory of relativity that there's a speed limit to light, and that's approximately 186,000 miles per second, and therefore everything else adjusts itself to that constant. Well, here is a violation of that, because if this particle is affected and it instantly affects this other particle, which is 10 light years away, that means it had to travel 10 times faster than the speed of light to get there. And that's a problem. But anyhow, every experiment that has ever been set up to test it has proven to be accurate. So, not to say people understand why it's true, but they understand that it's true. And so that kind of shattered everything. And of course there was another paradox that had come along, and that was what's called the black body radiation paradox. Even though I think it was Rutherford actually that said that we've discovered everything in physics that there is to discover, we just need to refine it. And there were a few missing links that needed a little bit further investigation, and dark body radiation was one. And that had to do with the fact that when you take a piece of metal and you start to heat it, it goes through certain color changes. And as it gets more heat radiation, it gets hotter, and as it gets hotter, it changes color. Now, it ultimately goes through some distinct colors and ultimately to white. Now, and that's because you kept adding more and more energy to it. It got quite hot. Okay, now the reason it gets colors is that when an electron absorbs energy, it gets going faster and or has more energy to move, let's put it that way. And so it suddenly disappears from the first orbit it's in, or the orbit it's in, and jumps to the next orbit. But it does it instantly without ever being found between those two orbits. And so that's, you've probably heard the phrase quantum jump. It disappears here, it shows up here, and it's never found in between. Okay, so what they said was, there's some reason why or how this occurs. That is, it goes to each energy level or orbit, it changes color when it gives off the energy and jumps back. And that energy could be white if it's all the way out and then jumps way back to its normal state, it gives off white light. And so this created a problem. They couldn't explain that. Why doesn't it go through all the colors of the rainbow instead of a few distinct colors in each of these orbits? So bottom line is, they found out that it follows a certain principle, and that was called Planck's constant. And so Planck was another physicist who had this inspiration that of a mathematical constant that explained, when you started to determine the movement from one orbit to another, why it disappeared in one and showed up in the other, but never in between. And when it's coming back down, it does the same thing. When it gives off the light of this orbit, it's immediately found in the orbit below. And so it was called Planck's constant. And so that became a major factor in calculating. In other words, all this stuff works out mathematically, but in our minds we're saying, how can that be? So I'm introducing some of this just to get you started, because I think you'll find it more palatable to look at radionics when you understand something about quantum physics. Now, we've only given you a few pieces of information about it. I have in my the same as on my website, I have Oshman's books. I have a few related to quantum physics. I would suggest, if this really intrigues you, that you may get those and read them. Now, for a very basic introduction to quantum physics, I would get the book called Taking the Quantum Leap by Fred Alan Wolf. It's F-R-E-D-A-L-A-N-W-O-L-F. He's a PhD quantum physicist, and he's written a series of books. But this one is a good starter book because without mathematics, he kind of introduces you to the concept of quantum physics. Now, he's written a whole series of books, and we've mentioned, I think, most of them over time, but pertinent to what we're talking about now, I would say, first of all, read Taking the Quantum Leap. Then I would read The Body Quantum, which is actually, I think, the second book he wrote, and how he shows how quantum physics operates within our body. Our nervous system and various functions of the body involve quantum physics, even all the way down to the DNA. And it's interesting, he introduces some tremendous information. Now, he has never republished that book. You may have difficulty finding it, but I think there are some copies out there used that you can probably find. But it's a tremendously good book to read, because he introduces a lot of facts about it. Now, he wrote another one called Starwave that had to do with consciousness and quantum concepts. That one is a little heady, and you might have some trouble with that. But I think most of you, if you read Taking the Quantum Leap, can understand most of The Body Quantum. A third one he wrote, which is one of these later ones, is called Mind into Matter. And I think you might find that one interesting. And he also wrote one called Matter into Emotions. So his material is always very good. He has a website. You can go to his website and find out a lot of information. But he's like what I call a very forward-thinking physicist. Another one that I want to throw in that is extremely important is a researcher, PhD in science and physics and so forth. And he was a consultant to the government. He worked at Stanford University in California as a research fellow. And on the side, over the 30 years he was there, he did his own research. When he retired, he wrote a book called Science and Human Transformation, which has to do with the effects of mind intention on matter. And then he started doing more research after he left the university, and he wrote one called Conscious Acts of Creation. Extremely good book. A lot more mathematics, but a lot of concepts that you will find interesting because, as I said, the magic word I threw in there was intention. And that's the key in both of those books to a lot of things happening. And it's an enjoyable read, even if you don't understand all the mathematics and put them aside. The first book doesn't have much math. The second one, Conscious Acts of Creation, had a lot more math in it, but it was written so that both physicists could understand from the mathematical side and other people could understand from the conceptual side. And it's very good material. So those are the textbooks for some of the stuff that we're going to talk about. And you'll find it intriguing because all of this is a consciousness stretch. What we're doing is stretching your thinking so that you see that the world is much more weird than we thought it was. We always thought everything is pretty well cut and dried. Science has laid out all these principles, and it's very simple. This is the way it works. To this day, medicine still pretty much ignores, although they don't always, but they don't know they're using it, ignores the quantum concepts in medicine. They still want to hang on to this, wow, this body is like a box of pieces and you can cut them out and you can manipulate them and you can do all these things. But that's the way the body works. And there is no such thing as consciousness other than that it's an artifact of the brain. The brain is all there is. Take out the brain, there can't be any consciousness. Anyhow, I've given you some background, some basics to get started. And so the next session, we're going to wade into radionics. Now, you might want to, if it really catches your attention, this one is called 21st Century Radionics by Nick Franks, F-R-A-N-K-S, and I think it's around 2010 publication. It's pretty new. And as I say, it's one of the newer ones that's been published. 2012, I'm sorry. Brand new. The other one I think is very good too is called The Secret Art, A Brief History of Radionic Technology for the Creative Individual. His name is Duncan Lowry. This also is very new. This is somewhere past 2000. It's 2009. Yeah, it's pretty new. So these are the two new ones that have come out in recent years. I have in my library books going way back for years and from around the world, but these are some of the new ones. And this will get you really going because they kind of examine it from a lot of different directions and some of the key players, and that's what we'll be talking about in the next time. So unfortunately, Mickey's big hand is pointing to one way and his little hand is pointing to another, which means it's time for me to get off of here. So I'm going to leave you. Now, next time I'll tell you about a basic course of radionics and radiesthesia that's free that you can get online and how to get that. And that will actually help you learn a little bit about some of the facts that we're going to be talking about. And they're beyond theory because they actually work, but they sound like they defy theories. At any rate, it was nice to be with you again. Don't forget to go to our website. Keep looking. We keep putting new material on, new pages, and so forth. It was nice to be with you. We look forward to seeing you the next time around. In the meantime, be healthy.